Then again, any geotechnical application, drainage is very important. Like especially like if you have an embankment which is above the ground, then the only water is coming is the rainfall actually. So that problem is less. But when it is a hillside, the groundwater table comes into the structure, then it becomes drainage becomes much more important actually. Then we should have probably chimney drain with a drainage blanket or pipes at intervals. We have to design that. Then this is one famous example, like it's in USA. It is a 70-meter high slope. I think it was 45-degree, but one of the highest slopes at that time. With a it had wraparound also with a vegetative facing. Then after construction, it was actually for an airport, what we call a tabletop airport in a hilly area. Suppose you want to get the runway length, you have to do a lot of filling, and for that we need this slope stabilization. So after about I think 8 years or something, there was a major failure. It collapsed. And the reason people say is we can see this failure because it was this filling was done against a existing hillside. So earlier some streams or what you call springs coming out. So probably they didn't put a good enough drainage system. So over a period of time that drainage was blocked. Earlier water was flowing out freely. Now you put a lot of soil against that was blocked. Then gradually pore pressures increased. Then finally the failure happened. So drainage is very, very important. Then another application was secondary reinforcement as a compaction aid. So here, as I mentioned earlier, when we make an embankment, getting proper compaction near the slope face is difficult because here in this zone there is no confinement actually. So when you run the roller, soil is free to move laterally, so it doesn't get compacted. So normally what is specified is you put, suppose this is my face, I put another probably half a meter extra, compact it, then you trim it back like that. In the specifications it is there, but nobody does it actually. So normally what happens, the surface actually it's very loose, and on that only you are putting your stone pitching. You can imagine how long it will stay. So this is a common problem. So one simple solution is use short lengths of reinforcement. It need to be just maybe 1.2 1.5 meter long at maybe 0.4 meter spacing like that. So it will improve the superficial stability. Then another application is if a slope has failed, we want to put it back like that. Because either we can make the slope steeper or we can use the same soil. Suppose why did that slope fail? Because factor safety was not adequate. So either we use a better quality soil or we'll have to make the slope flatter. Another option is because if it is a highway, we cannot make the slope flatter actually. So the only option is to go for a reinforced soil solution. Then this is a comparison between the walls, then steep slopes and shallow slopes. The major differences walls greater than 70-degree. So here the embedment is required, whereas in the case of slopes, it can start from the ground level itself. But then again, we'll have to look at each problem. If it is embedment is required, if you feel you have to provide for, but it's not mandatory as per the code. Then the failure plane, here it's ranked in two-part wedge and slip circle, which are all approximations or idealizations like that. Then facing wall, it is required. A steep slope, facing required. Shallow slope, facing is not required. We have to provide only erosion control. Then fill, here we need a good quality granular fill, whereas in the case of slopes, we can use. Then tolerance to deformations, mainly as I mentioned, soil can accommodate a lot of settlement because it's a flexible material. But in the case of wall, we are putting a facing, a concrete panel or blocks. So how much settlement the wall can tolerate, it is decided based on what type of facing I'm using. But in the case of slopes, normally with the wraparound, it can accommodate a lot of settlement. So if the foundation soil is poor, it's likely to settle, then the slope has advantages. Then bearing capacity, in the case of walls, it's more stringent. Slopes, like it's lesser. Even seismic, like, see, normally the peak ground acceleration we use, in the case of slopes, we take 50% of for the walls. Like, so if we compare the cost, like I have compared like two situations. Like, see, this is the height, one a reinforced soil wall with a back slope, or a conventional retaining wall with a back slope versus this steep slope. So normally you'll find this will be much more economical solution. So where does the saving comes from? One is like compared to reinforced soil wall, slopes require less reinforcement because the design methods are different actually. Like, then cost of facing, again for the slope will be less. Unit cost of fill, like the wall needs a very good quality granular fill, whereas for the slopes we can go up to 50% fines. That means most likely I can use a local soil. Even the volume of the fill, uh, we may not think like, look at here, like this is the steep slope actually. If I go for this, I need this much extra fill also. So that also I am saving here. Of course, like this is compared with the wall with the back slope. If I use a full height vertical retaining wall, of course, then slope needs more fill actually. Then ground preparation, because bearing capacity, settlement, like the walls are more stringent compared to slopes, then like no excavation like that. So even that cost will be less. So overall, we can expect the reinforced soil slope to be a much more economical solution. Then this is a simple like example. Like suppose, see, normally steeper than 70 degree, it's a wall. Less than that, it is a slope. So what I did, I took a 71 degree, designed it as a wall using MSCW. Then 69 degree slope, designed it as a slope using RESSA. So then reinforcement quantities, see, like there are number of layers, I multiplied by the length into the design strength actually, because cost wise it varies from place to place. So this quantity is given here like that. Like it's not a like a money cost actually, but in terms of the reinforcement length into design strength. So this is the difference actually. Like the slope is much more. We need lesser reinforcement. Then again, we can have a lot of applications in hill roads actually. So where we have to cut and fill, sometimes this part is cut, then we have to put the fill here. So we can do slopes only in the fill portion. Like wherever we are doing filling, we can think of this technology. Whereas for the cut, we'll have to think either if space is sufficient, go for a stable slope. Otherwise, like rock hangers or soil nails, breast walls, like whatever it is, we have to adopt. Then again, there are issues like that. Suppose I need a certain, provide for a certain length of the reinforcement. To provide that, I have to make an excavation here. So when I make that excavation, actually, I am increasing the height actually. And at that, what happens at that point of time? Stability need to be addressed. Like, because once it is constructed, it will be stable. But during construction, it takes some time. At that time, so people are working there. So in case at that time there is a slide, it's going to be a big mess actually. So that part also you have to check during construction. Then like we can have like a structures like I told like sorry, steeper than 70 degrees it's a wall, less than 70 degrees it's a slope like that. But within the same structure, it's possible like this part it is a wall, then we have steep slope, then we can have a shallow slopes like that. Then how do we design that like that? Like because we have some really tall structures in the country. Like one is Sikkim airport. It was I think about 80-meter height. So they have different angles actually, different sectors like that. Then recently, Kannur Airport in Kerala, like they are gone up to 90 meters. That's what I heard. Like, so there are so these kind of structure. Then how do I design? Do I design it as a wall? Do I design it as a slope? So normally in this kind of situations, we have to be more cautious actually. So probably because this part I can probably assume this to be a two-tiered wall, then probably think of some way of putting the surcharges like that, delays, then do the stability analysis, then do it as a slope with risk like that. Maybe 3-4 types of analysis we'll have to do like that. Because uh, like when you make something which does not fit into a standard category, like a conventional wall, I know how to design because we have a lot of experience, like a RCC wall. Similarly, reinforced soil walls, now we have a lot of experience likely. But these kind of, when we go outside our range of experience, then we'll have to be more careful. Because once there was a project in Kerala, like it's one of the biggest malls in India, so they made a retaining wall. Like it was, I think, just 4 or 5 meters high, but the foundation was very soft clay. So it was made by a consultant. So if you want to put a RCC wall, then they need very costly pile foundations. So what they did, they came with a something like a very unique, innovative structure. Like it was like a 200-meter RC, sorry, 200 thick RCC supported on under ream piles like that. So this is like not precast, like cast in situ RCC like that. Then they had some steel strips actually, again very wide, like probably I think 100 wide and very thick length like that. Then at the end like a RCC beam, like an anchor. So, and several like that. So, if you look at me, it's neither like in a RCC wall nor a reinforced soil, something like that. And the reason, basically, their intention was good actually to save the cost actually. But then somehow the consultant did the design. The contractor, he was not very confident actually. Then he, right from the beginning itself, he was telling this is going to fail, this is going to fail. Then the consultant, no problem like that. Then one day, I think after construction was complete, it collapsed, something like 30-meter long. And no, I don't know why it collapsed. I don't know. Like actually, I asked for the like design, but they didn't give. I did my own checking. I don't know if you analyze the tension and all, it should not have failed, but it failed actually like that. So when you go for this, like new type of things, more cautious. Then this is another interesting application. Like suppose I have a hill road actually. So we have the existing like hill like this. So here it's a narrow road. See now I want to widen this. So now what is the option? I have to do some additional filling. So one option is go for a reinforced soil wall. But for that I need a certain minimum length. So typically we know it's 0.7 times height I need. So if I make an excavation for that, like if suppose I need 0.7 comes here, then I'll have to excavate the existing road. So that means we'll have to close the road, which is not acceptable like that. So in this case, we have another option. We go for a something known as a shored MSE wall. See, MSE wall is mechanically stabilized earth, same as reinforced soil. Like in the US, they call it MSE, like mechanically stabilized earth. Like here, we can go with the lower reinforcement width. So here what we do is, like we excavate this, then do soil nailing. So this is the shoring, like. We go on excavating, put the nail, excavating, put the nail like that. Then we put the MSE, reinforced soil wall. So here the advantage is, like this is putting very little earth pressure on this actually. This part is stable, more or less stable with the shoring. So we can go for a lower reinforcement length actually. Then the upper 2-3 layers have to be longer. Otherwise, normally they find like there is a tension cracks develop because that. Or another technique is we can tie this reinforcement to the soil nail structure, to the shoring wall. That also is possible like that. So, like this. So again, this is a like especially for hill roads or other applications, like where we don't have enough space to accommodate the soil reinforcement length. This is a very good technique. And I think in India also this type of walls have been constructed. Companies, I think like Isatec, there is one company, they have done a structure. And I understand there is another company called Reinforced with India. They have also done few structures of this. Again, there is a FHWA guideline for this showed MSC walls. Like it's available on the net. And here also, like drainage is important. So to the conclude, like again, the reinforced soil slope is it's a proven versatile technology. Uh, Especially in India, like we need to explore this option more like that. Then the main advantage is using locally available soils. Then here also the phase treatment is important. Sometimes we get more emphasis on the calculations and design analysis, but detailing is also equally important, like construction proper phase treatment is very important. Then drainage is also very, very important. That I conclude. Thank you.